Good evening, everyone. Welcome to the NPTEL online certification course on the topic water and wastewater treatment. And as you all know, this course is being taken by Dr. Bhanu Prakash V from IIT Roorkee, and I am one of the teaching assistant. My name is Akash Saha, and I am a PMRS scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. Okay, so I'll be there with you throughout the course to help you. We will solve some problems and do some doubt clarifications. Okay, so as and whenever you have any doubts or any confusion is there, you can mail me. I'll be there to solve it, or else we can discuss the same things in the class. And apart from that, in the class we'll be solving some questions. We'll be doing majorly multiple choice questions. As you all know, you will be given some assignments. So to help you solve those assignments, we'll be solving some multiple choice questions, and through that we will go through each week's module. Okay, so today we'll be covering week 1. So this is the basic thing related to water and wastewater treatment. Okay, so today is just kind of introductory class, not much, like we won't be solving much problems, but the later classes will be having more and more problems. And apart from the MCQs, I will also focus on some subjective type of questions, though the same kind of questions will not be asked in the assignments or in the maybe in the final exams, but through solving one subjective question you will be able to tackle many different MCQs. Okay, so just to develop that problem solving skills, we'll be solving some subjective questions. Okay, so at this point, anyone has any queries? If you have any doubt or anything, yeah, please. Your voice is not clear. I think the network is weak. Can you write your question in the chat box? It will be better if you type it in the chat box. So as and when, if you have any doubts or any clarifications to be made, either you can unmute yourself and speak, or you can write the question in the chat box. Okay, so we'll try to address that. Right now, I think his voice was not clear, at least to me. So that's why I'm asking him to write in the chat box. But the easier way is to unmute and speak. Okay, okay, no problem. Okay, so we'll move on. Uh, I hope you are able to see the screen. So this is the basic overview of week 1 lectures. Okay, so as the course instructor, Dr. Bhanu Prakash sir, introduced you all to the importance of water and wastewater treatment. So we discussed about the waterborne diseases, about the germ theory, the cholera epidemic. So this was the starting, and then we discussed some life expectancy and the real world scenario related to this water and wastewater treatment. And then we moved on to some basic schematic and functions of these treatment plants related to the water and wastewater treatment. And after that, we moved on to some fundamentals related to the concentrations, how to convert from one concentration type to another, what are the different material flows and material balances in and out of system boundary. Okay, so we'll be discussing more and more about these things. Okay, so these are the basic concepts. So today we will just discuss some multiple choice questions based on these topics. Okay, so don't worry if some questions, they may seem to be difficult at first, but through this course we'll be able to solve them. And also, some questions might seem very easy to some of you. Okay, but this in this course there are many kind of people who are joining, starting from students to some professors and everyone. So we will try to address each and everyone's issues, and we will try to solve all kinds of problems. Okay, so don't worry. If you have any question, confusion, you can stop me right there. Okay, so we'll start with the first MCQ. So it says that which of the following are water-borne diseases? So we have talked in the modules about the water-borne diseases. So the options are cholera, asthma, influenza, and typhoid. So please write your answers in the chat box. so that we can discuss whatever you feel like is the correct answer for this question. Okay, A. We got an answer as A. Anyone else? A and C. Okay, let's see. Anybody else has any different opinion about this question? So it is talking about water-borne diseases. Okay, one more answer. We got D. So mind you, some questions there may be more than one correct answers. Okay, so it's not that every time there will be only a single correct answer. There may be times that there may be more than one correct answer. Okay, so generally the general uh, trend of answering is A. So absolutely, cholera is one of the major waterborne diseases, and apart from that, as Haritra told, D, typhoid. So typhoid is another answer. So both option A and D are correct. So if we see the explanation, we can see that these waterborne diseases are caused due to the exposure to contaminated water. Okay, and these diseases are caused by the various kind of bacteria, viruses, protozoa, toxins, whereas this asthma and influenza are majorly airborne. Okay, so these are triggered by allergens in the air and not through contaminated water. And influenza also, it is spread through air by infected people through coughing, sneezing, or talking. Okay, so the major waterborne diseases are cholera. Yeah, but no, these are basically waterborne. Okay, let me show you some more explanation. Just a minute. Yeah. So you can see that there are four kinds of major classifications in water related diseases. So we have water borne diseases, we have water based diseases, we have water related vector borne diseases, and we have water source or water washed diseases. Okay, so if we see water borne, these are caused due to drinking water contaminated by human or animal feces, okay, which contains the pathogenic organisms. So cholera is the example of it. Then there are water based diseases. So these are caused by parasites. Okay, these are caused by parasites that live in the water and infect humans through skin contact or ingestions. Okay, so schistosomiasis is one of the example, which is caused by a parasitic worms in fresh water. And then there are water related vector borne diseases. Okay, so there are many vectors, as someone has mentioned, like mosquitoes. Okay, so that breed in the water or near the water, like diseases like malaria are caused by this. And then there are water washed or water source diseases. So these are related to poor hygiene conditions. Okay, so either through skin or eye contact of the contaminated water. So one example is trachoma. Okay, so I hope you are clear with this, and I like addressed your question. So these are the major classifications. Okay, so what are related to water based diseases: water borne diseases, water based diseases, water related vector borne diseases, and water source or water washed diseases, right? Okay, so we'll move on. Okay, this is the next question. So in the given figure below, the course of the river is shown. Okay, a river that is flowing through A, B, and C areas. Okay, so as it passes through the different areas, it accumulates different type of contaminants. So match the locations A, B, C shown in the figure with the probable contaminants that may be present. So there is an agricultural land, there is a forest, and there is a built up area, urban built up area. So what kind of probable contaminants that may be present while the river passes through them? Okay, so go through the options. So we have various kinds of contaminants, starting from pathogens, suspended solids, then nutrients, heavy metals, organic matters. So uh, just go through the basic general type of contaminants. Okay, don't dig deeper into them. Okay, two option two, many one Many people are saying it's at option 2. Let's see other answers. Just a minute. There are new people, those who are joining. Okay, so for the people who have joined just now, so I would request them to check the Google Sheet or the Google spreadsheet that I have shared in the chat box. You please fill in the details. So basic name and email is required so that I can share some resources or information or any kind of doubt clarification that is required through that mail ID. Okay, so these are the basic details that are required. And apart from that, for the new joiners, so I'll be your teaching assistant. My name is Akash Saha, and I am a PMRF scholar at IIT Madras, where I'm pursuing my PhD in environmental engineering. Okay, so I'll be there to help you out in this course, and we'll be mostly solving MCQs in the problem solving sessions, and also some subjective types of problems. Okay, and apart from that, if you have any doubts, you can let me know. And also, suppose if you want some concepts to be repeated, or you want me to like take a small session uh, on that, so you can drop a mail. Okay, just a minute. I think I lost connection. Guys, am I audible?
Yes,
Okay, okay. Just I think the screen, you are not able to see the screen, right?
yes, sir.
Yeah, I think it's fine now. You're able to see the screen. So yeah, as we were discussing this problem, so we have locations A, B, and C. So let's see. The first location is agricultural land. So as many of you are answering, okay, it has option 2. So A means 2. That means it will be heavily contaminated with nutrients in the form of phosphorus and nitrogen, and heavy metals or organic matter. Okay, so these nutrients are mainly coming from these fertilizers and all, because the plants require these nutrients, and there are some in the soil also. And then if we see the forest area, that is the B area, it will be mostly organic matter. All right. So mostly organic matter will be present in the forest area. And if we see the urban built up area, so there we will see all sorts of pathogens, suspended solids, some nutrients, heavy metals, organic matter. So it will be a combination of each and everything. So that's why the correct answer is option 2. Right. I hope this is clear to all of you. There is no confusion in this. Very simple question. Okay, we'll move forward. Adequate wastewater treatment can contribute to achieving which of the following UN Sustainable Development Goals, or the SDGs? Okay, so we have SDG 11, Sustainable Cities and Communities, SDG 6, Clean Water and Sanitation, SDG 4, Quality Education, SDG 3, Good Health and Well-being. So if we are providing adequate wastewater treatment, then which of these SDGs are being targeted or achieved? B and D. Okay. B and D. Fine. Anyone else? I see only few people answering again and again. So others also, please. You can just whatever you feel like. We can discuss, right? There is no problem. If you have any difference of opinion, also we can discuss. So mostly people are saying B, which is very logical because if we are providing wastewater treatment, then ultimately we are providing clean water and sanitation. So wastewater treatment is directly linked with sanitation. So definitely SDG 6 is being achieved if we do this. Apart from this, as some people have mentioned, good health and well-being, because sanitation is directly related to the hygiene, to the diseases, to everything related to the human beings' health and their well-being. So SDG 3 is also being targeted. And apart from this, it also helps in achieving SDG 11, which is sustainable cities and communities. So what do you mean by sustainable cities and communities? We mean that the city's development or the resources that we are using, okay, for developing a city or a community is being used sustainably. So if we do adequate wastewater treatment, what we can do? We can treat to such an extent that we can recycle the same water for various purposes. Okay. So by doing this, what we are doing is we are limiting our requirement of fresh water. So it is directly linked to with sustainability, right? Is there any difference of opinion? I don't think so. So SDG 11 will also be achieved if we provide adequate wastewater treatment. So all the options A, B and D are achieved. So you can here see a snapshot of the all 17 SDGs, starting from no poverty, zero hunger, good health and well-being. So like that 17 sustainable development goals are there. And some way, some of them will be interlinked. And many of them, I think, I think around six or seven are directly linked with water. But here we are only talking about wastewater treatment, but many of them. So this has been given by the United Nations. Okay, so you are seeing that there is a major concern of climate change. Okay, the average temperature throughout the globe is increasing. And why it is increasing? Because of the rapid utilization of the resources. Okay, there is urbanization, there is a population growth. We are using more and more and more resources, right? So there should be some kind of action that has to be taken. Okay, so for that, the United Nations has given these 17 sustainable development goals, and you can go through because each and every goal will have subsections. Okay, it's not just we say no poverty, but how to achieve that no poverty. So there will be various subsections. So you can go to the website, you just simply write SDGs, and you can go through each of them, and then you can try to relate that how water or wastewater treatment is interlinked in achieving those uh, sustainable development goals, right? So as you can see, like life below water, there is something as life below water, SDG 17. So this is also related, right? Responsible consumption and production. Okay, so these are all somehow interlinked with each other. Okay, though they may look different goals, but they are also interrelated. Yes, I think that it should be mandated for all the industries. I don't know how that, like it depends on the government on how much they are enforcing, right? But if we are able to mandate these SDGs on the industries, definitely it will be better, right? So it depends on the country's government on how far they are able to enforce these laws. And there are various parts of this. There are various acts and provisions that are being given to various kind of industries. Some are heavily polluting, some are less polluting, small scale, large scale. So depending on the type of industries and the type of government, it all functions, right? Okay, so we'll move forward. Next is hardness in water causes joint related issues, digestive issues, fluorosis, cholera. So can someone tell me, like, due to what causes hardness? Just a simple question. What causes hardness? Any answer? Salt, okay. But what do you mean by hardness? Like, if we are going to define hardness, what are the major elements? Is it only carbonates and bicarbonates? Yes, Shashmina, you want to say something?
Calcium, magnesium, bicarbonates, carbonates.
Yeah, so basically any kind of divalent or multivalent cations like calcium, magnesium, even aluminium. So it should be either divalent, not monovalent, not sodium, right? It should not be sodium. So any kind of multivalent cations, if it is present in the water, it will cause hardness. And majorly in our water, these are calcium and magnesium. So that's why we are more concerned about their salts. Okay, so these calcium and magnesium can combine with various kind of carbonates or bicarbonates or sulfates, right? So there are various kind of hardness, temporary hardness, permanent hardness. So these carbonate, bicarbonate are temporary hardness. These can be easily removed by boiling. Whereas if there is a non-carbonate hardness like sulfates, these cannot be removed by simply boiling. Okay, so we'll go more into these details in the later classes. So, so coming back to the question, so hardness can cause, so so there are various kinds of answer we are getting. So first of all, if we see fluorosis, so many people are answering it as C. Okay, so fluorosis, as the name suggests, is it is due to fluoride. Okay, but fluoride is not a multivalent cation, right? It's an anion. That is also a monovalent anion, F minus. So that definitely fluorosis will not be caused due to hardness. Hardness, we are talking about only multivalent cations. Then cholera. Cholera also we just discussed in the first question that it is caused due to the water contamination due to various kinds of, yeah, microorganisms. So the hardness in water will cause mostly joint related issues and digestive issues. Okay, so these are the two answers, option A and option B, because these will cause some kind of laxative effect, which will cause some digestive issues. So when we are talking about hardness, just keep in mind it's only the multivalent cations. Don't go in terms of carbonate and bicarbonates. Yes, they will combine with them. They will combine with them, but we define as per the multivalent cations. Okay, next question. Groundwater of a tier 2 town was found to be contaminated with fecal coliforms. What may be the possible reason for this? Is it fecal coliforms are naturally occurring in soil, rainwater infiltration, leaching of sewage from septic tanks, collecting fecal waste from individual households, infiltration from irrigated agricultural lands? So we have four options, and just keep in mind that we are talking about a tier 2 town. It's not about a metro city or an
C
urban
answer
developed
maybe.
town. Okay, so many people are answering it as C. Okay. So if you are answering it as C, can someone tell me, like, what is the use of a septic tank? Why do we generally use it? Any answer? And what is the reason that there is a leaching in the septic tank? So mostly in the tier 2 towns.
अरे ये ना
Okay.
तुम्हें टाइम पास करके उस टाइम हाँ
See,
हाँ
can you unmute yourself?
सर सेफ्टी टैंक
हाँ.
जो होता है तो
Yes.
जहाँ पर सीवेज सीवर लाइन नहीं है वहाँ पे सीवेज कलेक्ट करने के लिए बनाया जाता है ना
Yes, definitely. Yes.
और
The
इंटरवल के बाद उसको सक्शन मशीन से स्लज वो स्लज और वो स्लज वाटर जो है उस सक करके फिर से ये में लिया जाता है
Yes, yes, right, absolutely right. This is the correct reason, because in many tier 2 towns where we don't have a sewerage network, okay, to take that
यस
sewage from your like from the household to a
ये तो
treatment system, we will put it into a septic tank.
हाँ सर
Okay, so there
यस
there will be not a full degradation of the organic matter. Okay, we won't get any 90 to 100% of degradation, but there is some degradation of this organic matter, and then whatever is remaining, the sludge that is remaining, as you pointed out, we will take out after a period of time, maybe 6 months or 1 year, whenever the capacity of the septic tank will be getting filled. Sir, can you please unmute yourself? Can mute yourself?
हाँ सर
Can you please mute yourself? There is a lot of background noise. आप म्यूट कर दीजिए अपने आप को थोड़ा.
यस यस
Yeah, yeah, thank you. So yeah, so mostly this septic tank should have a bottom lining so that there is no leaching. But in most places in India, that is not the case. They will simply dug the ground, okay, and they will put the sewage directly into that. So what happens is there is some kind of leaching, okay, leaching of this organic matter or pathogens or any kind of heavy metals, whatever are there, it is getting leached out from the septic tank system, okay, and then it is going into the groundwater. So that is a major issue, that it is getting contaminated with all kinds of fecal coliform, because the septic tank will not do any kind of disinfection. Okay, so these fecal coliforms will contaminate the groundwater as it will slowly leach out. There is no lining, and also some things has to be kept in mind, that generally whatever the effluent that is coming out from the sewage tank or or the septic tank, it has to go through some soil absorption techniques or some absorption trenches, disposal trenches. Okay, so these are also required for the effluent of the septic tank.
soak pit is also required
Soak
for
pits, yes,
yes sir
soak pits, yes, definitely. These are absorption systems which are called soak pits or disposal trenches. So these are required for the effluent of the septic tank. Okay, so we'll discuss about these in detail in the later part, just to give an idea. So definitely option C is the correct answer, that leaching of these sewage from the septic tank, collecting fecal waste from individual households, will go to the groundwater and contaminate with the fecal coliform, right? I hope it is clear to all of you. We'll move forward. So
yes
yeah,
sir yes sir
this again. See, safe distance. Yeah, there should be some. I don't know the exact number, like what should be the safe distance, but definitely there should be some like distance, and also the major thing is the septic tank from the bottom and from the side, it should be lined. Okay, there should be lining of some maybe concrete or any other stones or some brick bats, everything. There should be some lining so that we can minimize the extent of leaching. Even if the groundwater level, suppose it's very high, okay, we are not getting much distance. If we are doing lining, then that is much better. Okay, but in India, due to various kinds of issues, those lining itself are not there. Okay, right? Okay, we'll move to the next question. Which type of reactor is a closed system where the concentration changes only due to reaction? Okay, so we have different kinds of reactors. We have a batch reactor, we have continuously stirred tank reactor, we have the plug flow reactor, and all of the above. So where it is a closed system and the concentrations changes only due to the reaction.
ये सिक्वेंशियल बैच रिएक्टर में होता है सर एसबीआर टेक्नोलॉजी पर
sequential batch reactor, yes. So that's what we are talking about. So it's a batch reactor. Okay, so whenever we are
Yes, sir.
talking about a batch reactor, okay, there is no inflow and there is no outflow continuous. Whereas in the case of a continuous stir tank reactor, as in the case of maybe if you see the aeration tank of an ASP, okay, so there is
Uh,
continuous inflow and outflow that is going on in the system. Okay, whereas in a batch reactor, all the things will be put in. Okay, it will be closed. The
uh,
reaction will go on, the degradation will go on, and at last we will take it out. There is not a continuous flow. And also, if we see the flat
uh,
flow reactor, there also sequentially it moves. The uh, the wastewater or whatever that
yes.
is getting treated, it will move in the lateral direction. So there is some movement. It's not a closed system throughout. Okay, so the correct answer is a batch reactor. So a batch
Yeah.
reactor is a chemical reactor in which is a non-continuous reaction is conducted. That is where the reactants, products, solvents do not flow in and out of the vessel. Okay, they are not flowing in and out of the
Yes.
vessel continuously until the target reaction concentration is achieved.
Yeah,
Okay,
it
so
is
we
in three steps, sir. Aeration, decanting, filling aeration or decanting.
yeah.
इस तरह से.
Okay, so we will decide how much time we have to give it. So based on the time till the system achieves that particular target conversion, till then we will operate. So this is the batch reactor. I hope it is clear. We'll move to the next question.
Yes.
Yeah. Are you able to see the next question?
No, sir. I am actually on the
Ah,
mobile.
yeah, yeah. You can mute yourself,
Yes.
sir. No problem. We can.
Yes. Yes.
Yeah. So the question says advection is a bulk movement of fluid in one direction. Okay. So what do you mean by advection? Whenever something is being moved or transported due to the bulk action of fluid. Okay, and it is generally in one direction. It is through the x-axis or the y-axis, whatever axis we define, it is through one direction. So definitely it is true. So I am not going to discuss much about it. So advection is a transport of a substance or quantity by bulk motion of a fluid. Okay, and all the properties of the substances are carried on with it. Okay, so whatever the properties we have, it will be carried with the bulk motion of the fluid. Right? Coming to the next question. It says that equalization of the influent flow in a wastewater treatment plant is done to prevent shock loading. Is it true or false? So we are talking about equalization of the.
I think it is false.
Why do you think so?
It's- सर अभी प्रिवेंट शॉक ये लिखे ना प्रिवेंट शॉक
Yes.
लोडिंग.
Yes.
हाँ, that's why I'm saying that.
No, see, by shock loading, I mean to say that we are protecting the system from a sudden increase in the flow rate. Okay, okay. Or
Hmm.
what else? So what so others, I am asking others also. What do you think the equalization tank does? What are the two main criterias that it takes care? One I told. One is the flow rate. What is the other thing?
Um,
Others, you can also try.
maybe the sewage content.
Yeah, it is. So basically, it's a concentration. Whatever the concentration of organic
हाँ,
matter
yes sir.
or anything contaminants, it is. So what equalization tank does is that it collects everything, okay, and then lets out only the average flow rate and the concentration. So in that way, it is able to prevent the shock loading. Okay, so it
Yes sir.
involves the uses of a storage tank, okay, to temporarily hold the wastewater so that it allows the flow rate and the polluted concentration to be averaged out over time. Okay, so over a time it temporarily keeps it there. Okay, so over a period of time everything is averaged out. So if there is any shock loading also, by shock loading I mean more concentration or more flow rate, so it will be averaged out, right? So it's a temporary storage of the incoming wastewater, right? So the answer is true. Next question. The compound used by Dr. John Snow to curb cholera is dash agent. So we have to find out which is that. We have to fill in the blanks. Either is it oxidizing, reducing, biological, or none of the above. So when there was a cholera outbreak, so Dr. John Snow used some kind of compound. Okay, some kind of
Yes.
compound. So can someone tell me what was the compound? We'll get to the other part.
Poly, polymer dosing, sir.
No, not polymer dosing. So in the first question we discussed about cholera, right? It is a it is a water.
Biological, I think.
Biological. Okay, so let's discuss it. Let's discuss it. So, cholera is due to the water contamination, and yeah, as Haritra has rightly pointed out, it is chlorine. They have done chlorination because this cholera is being caused by the contaminated water due to the microorganisms. And to kill or to remove these microorganisms, we need some kind of disinfection technique, disinfectant in normal terms. So it is chlorine. We do chlorination, and as you all know, chlorine is a very electronegative element, right? It is highly electronegative. So what it will try to do, it can easily take out electrons from other atoms, okay, and give and convert them into ions. So in that way, whenever we are taking out electrons, what we are doing, we are oxidizing it. We are oxidizing it, right? So chlorine is highly electronegative, and due to its property, it is able to easily take out electrons from the other atoms, okay, or maybe, and in this way it is able to disinfect. It is able to disinfect the microorganisms. Okay, so it's a very strong oxidizing agent, and hence it is an oxidizing agent. Many people are answering it as biological, but it is an oxidizing agent, right? I hope it is clear. We'll move forward. Select the correct option. So you have to say true or false. Germ theory states that certain diseases are caused by the invasion of the body by microorganisms which are too small to be seen except through a microscope. So we are talking about germ theory.
Yes, true, yes, sir.
True, true. Yeah,
Yes, sir.
yeah, right. So it is true.
Mm.
So we will discuss a little about the germ theory, right? So we can
Yes.
say that uh, germ theory of disease is the currently accepted scientific theory for many kinds of diseases. Okay, and it states that the microorganisms are known as pathogens or germs can cause a disease. And these microorganisms cannot be seen without magnification. Okay.
Tanti mama guru.
Sir, can you please mute yourself? There is a lot of background noise. Others are getting disturbed. Yeah, thank you. So these microorganisms are so small that they cannot be seen without magnification. Okay, and they may be invading the humans, and they may be living as parasites. Okay, and their growth and reproduction can cause within the host can cause various kind of diseases. And the germ, by germ we don't only mean bacteria. There can be any kind of microorganism. It can be a fungi or a virus or a protists or a prions, anything. It can be anything, right? So this is the basic germ theory. Next question. So it says that which of the following reactor types provides the highest conversion per unit volume for a first order reaction? So is it a batch reactor, a CSTR, a PFR, or a fluidized bed reactor? So by highest conversion per unit volume is, so you can say for the smallest volume, okay, which will give the same degradation. Okay, if I make three reactors, one as a batch reactor, one as a CSTR, one as a PFR. And I want to convert, suppose I have 100 milligram per liter of COD, okay, and I want to bring it to, like, suppose 10 milligram per liter of COD. So the amount of treatment that is required is same in all the reactors. So which of the reactor will have the smallest volume? So if you have the smallest volume, it will be the highest conversion, right? So I'm getting few answers. I got the one answer as C. Can someone tell me why PFR will be the best or will have the least volume? We are saying it the best because we are concerned about the footprint of the reactor, because we don't have much space. So uh, we all would like to want to have a small reactor, okay, in our treatment system to give the maximum efficiency. So just think in terms of volume and why PFR will be a better option. Any reason, anyone? Okay, so PFR is definitely the correct answer, but I think we will read much more in detail in the next week. So probably you might not be knowing about PFR in much detail right now. So PFR is nothing but a plug flow reactor. Okay, and like there is no back mixing. Okay, and the reactants, okay, it flows through the reactor, and there is a concentration gradient always, and this concentration gradient is the major driving force for the degradation. Okay, so for the high degradation, so there is always some concentration gradient. We will learn more about this. Probably this is not the right stage to discuss this in detail. We will discuss this with much more clarity in the next, where we will derive some like what is the time period, what is the volume for each kind of reactor. So I think that will be the better that will be the better time to discuss about this. So right now you just keep it in mind that PFR is the best reactor if we want to have the least volume, right? Just keep that in mind. Okay, next question. It's very simple and direct. Here we are talking about the acceptable limits for the drinking water. Okay, so we have the Indian standards. Can someone tell me what is the number of this IS code for drinking water standards? Anyone? What is the number?
10500
Yes.
dash 2012.
Yeah, so 10500. Okay, that is, yeah, yeah, that is definitely. And 2012 is the year. Okay, so you don't have to say it. Yeah, it is better to mention the year also, because when the codal provision changes, we should know. But the basic number is 10500. Okay, so now tell me which of the statements are correct, because there are some acceptable limits for different kinds of physical and biological and chemical parameters. So we have here pH, TDS, total hardness, and nitrates. Okay. Okay, so many people are saying A is correct. That is okay. Some people have also said C. So can someone tell me if B and D are wrong? So what is the correct answer for those? So what is the acceptable limit of TDS and nitrates? Can someone tell me? I think B is not correct.
TDS maximum less than 500 ppm.
Okay. Anyone else? D 45. Okay. Okay. So we can see the answers. So correct answers are A and C. pH range of 6.5 to 8.5 is definitely correct. And hardness also less than 200 milligram per liter. This is correct. But if we see, so in pH there is no relaxation. Okay, but for TDS it should be less than 500, not 700. It should be less than 500. And in the absence of any alternate source, there is some relaxation that is provided, that is less than 2000 milligram per liter. So you also have to keep in mind this parameter. It's not only always about the acceptable limit, it's also about in the case of any alternate source that is absent. Okay, so what will be the limit? The limit changes at that time. So it is 2000 when there is no alternate source. Now coming to the hardness, it is 200. Okay, in general it is 200, but again in absence of any alternate source it is 600. Okay, so
Sir,
if you
one more question.
yeah,
Excuse me, sir. If pH greater than 8.5, what happened in human body?
in human body, uh, see there won't be, so it is becoming more and more basic, right? In human body you will definitely feel some changes, no it because
Yes.
the general should be, in general it should be 7. If more and more, if you're adding basic things, definitely like NaOH or anything, it will definitely cause disturbance in your body. I am not able to say
Is
what
what I
exactly, but yeah, definitely it should not be very high. 8.59 it's fine till that. I don't know about the exact
actually,
medical.
sir, in my company, drinking water parameter is 10.3 pH. Currently, pH in drinking water parameter in my company 10.3. So I want to know what the diseases cause of the high pH.
Okay, done. I'm not sure about the diseases. Maybe I will get back to you. Okay, I'm not sure what are the diseases,
Okay,
but in
thank you,
general,
sir.
it should be 6.5 to 8.5. Okay, right now I'm not able to recollect like
Thank you,
what
sir.
will be the disease. Okay, so
Okay, sir.
uh, coming to, but what industry is it? Can you tell me what is the industry?
Industry is paper mill, but only drinking water system is established for labor and other so persons drinking purpose. Before 2 days, I check parameters and I found that pH is greater than pH 10.3.
Okay, oh, okay, that should not be the case. Ideally, that should not be the case. Okay, based on like how we are using that water, based on the different uses of water, the pH limits can be definitely be different, but not for drinking water. Not for drinking. There is no relaxation. It should be 6.5 to 8.5. Okay.
Okay, sir. Okay, okay. Correct, correct.
Okay, then coming at to nitrates, as someone rightly. Yeah, that is true. In villages, it is very difficult to maintain these values, and even the RO systems, after a point of time, okay, that will it will not be giving these. Maybe in the start they will be providing these limits, but after a period of time, if you are not changing the system or it is not operated properly, the membranes. The major problem with the membranes is the fouling. Okay, so if more and more fouling is happening, the output also gets less, and the quality also gets degraded, right? So there is a need of better operation and maintenance also, which is not taken care after a period of time. So that is the major problem, right? Fine, we will move forward because there are many questions still left and we are just in the 12th question. But it's good that we are having some discussion also. Okay, total coliforms are a possible indicator of very direct fecal coliform or chemical contamination. A, that is, I think everyone will be familiar with this. So it's a possible indicator, right? So fecal contamination. So we can say the total coliform gives a count of the general indication of the sanitary condition. Okay, and these coliforms include bacteria that are found in soil, in water that has been influenced by surface water or human and animal waste. So it's a possible indicator. Very simple. Next question. Which of the following a typical sand filter cannot remove at all? Is it virus, algae, cyst, or bacteria? So suppose we have a sand filter. Okay. So which of the organisms it cannot remove easily? So definitely the sand filter will have more pore size than the size of the bacteria, than the size of the organism that it can't remove. Okay, so if we see viruses have a very smaller size. Okay, so virus is the correct answer, and their size uh, ranges in the nanometer levels. Okay, whereas in a typical sand filter, that it will be in microns. The pore size and all will be in microns. So definitely it won't be able to hold on to it. Okay, and there may be some part of bacteria, some kind of cyst also, or algae also, that may not be removed, but in generally these can be easily removed with the help of these sand filters. Okay, because we have a huge diversity in this bacteria and algae also. So maybe there are some bacterium which may not be good, but in general a sand filter can remove, typically 60-70% it can easily remove, right? So virus is the correct answer for this. Next problem: match the type of treatment with their primary function. So we have preliminary treatment, disinfection, primary treatment, and secondary treatment. So what are their primary functions? And one more thing, those who are there right now in the class, please try to fill in the Google Sheet that I have pinned in the chat box. So you can scroll to the top of the chat box and you will find a Google Sheet. Just give your name and email address. That's enough. Okay, you can put in your affiliation also. Just if in case I want to share some extra resources or materials with you guys uh, in a later point of time, okay, or any kind of updates regarding the class, I'll be able to do it through the mail, right? So just give your email addresses. It will be helpful. Okay, so I'm getting answers as A. So if you see, it is the correct answer. So in preliminary treatment, what we do, we try to remove all kinds of bigger size particles or the sand, silt, everything. Okay, or any kind of floatables or whatever is there. Preliminary treatment through screens or grid chambers, we will try to remove them. Then disinfection we have talked enough in the cholera epidemic. It is remove the microorganisms or the pathogens, right? Then we have the primary treatment. So primary treatment, after the removal of the sand, silt, all these materials, there are some comparatively smaller sites but suspended particles. So with the help of primary treatment, okay, Google form is not pinned. Okay, I will paste it again. Just a minute. Yeah, yeah, you can use this link. Others can use this link. I have pinned it. This. Okay, so where was I? Yeah, primary treatment to remove the suspended solids, and then the secondary treatment to remove the BOD or the organics. We will mainly focused into organics. So this is again the same things. And then if we see the tertiary treatment, it is used to remove the nutrients or emerging contaminants or all those things. So we have preliminary, primary, secondary, tertiary, and disinfection. Next problem. Okay, so a small very small numerical. So we have a concentration of calcium carbonate as 250 milligram per liter, and you have to find out the concentrations in ppm, in milliequivalents per liter, in ppb, and millimolar per liter. Millimoles per liter, yeah. So, so a very small workout. I'll solve it. I will solve this if you are not able to do this. So don't worry about it. Others who are able to solve, please try it. C. Okay. Anyone else? Okay, let's see how to solve this. We'll see how to solve this. So I will be solving some of the numericals in my notepad. So I hope you are able to see. So first question was in terms of ppm, right? So we generally say that 1 ppm is equal to how many milligram per liter? Can someone say 1 ppm is how many
One,
milligram? 1.
1000.
1000 ppm
No,
milligram per liter.
no, 1 ppm is 1 milligram.
1000 ppb.
ppb, yeah, yeah, that is true. 1000 ppb. So therefore, so we have 250 milligram per liter, right? So 250 milligram per liter will be corresponding to 250 ppm,
Okay.
right? Right. Now second was in terms of milli equivalents per liter. So there is a concept of equivalence. So now first what we'll do, we will try to find out the molar mass. So what is the molar mass of calcium carbonate? What is the molar
Sir,
mass of
100.
calcium? Sorry, you can type in the chat box. So we have CaCO3. I am asking molar mass. So Ca plus C plus O into 3. So it's 100 because 40 plus 12.
48.
Is it 48?
ACO3. Yes, 16 into 3, 48. Yeah, oxygen 16 into 3, 48.
Yeah. So it will be 16 into 3, right? So it is 100. Fine.
Yes, sir, yes.
No, because someone wrote it as 48. So so complete is 100, right? Now what is the equivalent weight?
50
So how we are getting 50? Because CaCO3, the
divided by
combining
2.
capacity is 2. So 100
Yes,
by
yes.
2 is 50, right?
50. Yes, sir, yes.
So it is
Yes, sir.
50 gram per G per equivalent, or we can say 100 grams, like that. Now if we see CaCO3 in milli equivalent per liter, milli equivalent per liter, how we have to do it? So we know we have 250 milligram per liter, right? We will
Yes, sir.
multiply it with 1 equivalent per 50 gram of CaCO3. We got, right? 1 equivalent per 50 gram of CaCO3 into, we'll change 1 gram to 1000 milligram because we have to find in milli equivalents per liter, right? So it will be equal to 5 milli equivalents per liter. So simply we have to do it. Is it okay? Right? Now the third one. So third one, as we all know, 1 ppm is equal to 1000 ppb, right? 1000 ppb. So therefore, 250 milligram per liter is equal to 250 ppm is equal to 250 into 1000 ppb, or 250000. Right. So again, 1 ppm is equal to, okay, second option. So second option, first, again, see, for the second option, first you find the molar mass. Okay, molar mass. Molar mass is 100, right? Molar mass is 100. Then equivalent weight we have to find. Equivalent weight is how much? 100 by 2 is equal to 50. So 50 gram per equivalence. Okay, one equivalent will have 50 grams of calcium carbonate. Okay, one have 50. Now we are given 250 as concentration. Okay, we are given 250 as concentration. So how many equivalents are there in 250? Just divide by
5.
50. So 5. Okay, now to convert that gram into milligram, we have done in thousand. So that was the final answer was in milli equivalents, not in equivalents. It was in milli equivalents. So just that conversion was there. So don't worry about that conversion. Just do it in terms of this. Is it okay?
Yes, sir. Yes, sir.
Okay. For others, I think it's fine. Yeah. Now the last one. Now the last one. Now again, 1 mole of calcium carbonate is how much gram? We just wrote 1 mole is equal to how much gram? It is the molar mass, right? It's 100 gram. Okay, 100 G. Now, 1 millimole. What is 1 millimolar? Is it? It's nothing but 1 mole by 1000, right? 1 mole by 1000. Okay, so what will be my 250 milligram per liter? So how much will be 250 milligram per liter? By how much we have to divide? So what is the molar mass? Same thing, by 100. So it will be 2.5. Okay, so it will be 2.5 millimole per liter. Is it fine? So these small calculations you have to do. Okay, we will solve some more questions. You will get a hold of this slowly. Just keep a note of what is mole. Okay, how much is what is mole? What is equivalence? Okay, equivalence, mole equivalence. Then what is molarity? Okay, what is molality? All those things, and what is normality? All these things you have to take care. Then you can ppm, ppb, so you can convert from one thing to other. You will solve some more questions, so you will get a hold of this. I think it's fine for at this stage. It is fine for you. Okay, so correct answer is option B. So the same thing in detail I have given. Okay, and don't worry, you will get the access for this ppt also. Whatever I am teaching, whatever I am discussing today, this PPT will also be shared. So always you can go back again if you have any doubts through all the solutions. And this YouTube lecture will also be uploaded. This lecture, whatever we are taking now, it is getting recorded and it will be uploaded in the YouTube. Okay, so you can always go back to the lecture. Fine.
Sir, YouTube channel, sir.
Yeah, you will get all the information. It will be shared. You will get a Google sheet where the link for this PPT and this YouTube, everything will be, YouTube channel will all be there. Or else you
Okay,
can
sir.
just, in YouTube you can just type in Akash Saha, my name, Akash Saha, NPTEL, NPTEL. Okay, if you
Okay,
just write it,
okay,
you will get my channel. There you will get
okay,
access to all the lectures. So if I'm taking the class now, so by tomorrow morning, positively, mostly I will upload the lecture. Okay, so
okay, sir.
if not today, this PPT link will be shared to you through the NPTEL team. Okay, so don't worry about
Okay.
it. Right. Next question. The mass transport in advection is along the direction lateral to fluid flow, and in diffusion, it is more apparent in the direction of flow. True or false? So we are talking about advection and we are talking about diffusion. So one is towards the flow, one is lateral to the flow. Yeah, so everyone is answering it as B, false, because advection is, as we discussed in the previous problem, it's towards the flow, whereas diffusion is like all around, like laterally it will be happening, right? So it is false. Okay, next problem. In the image below, each graph depicts a type of mass transport. Choose the correct option. So either it is advection, either it is diffusion, or it is advection and diffusion. Okay, so which is the correct option? So here we have been given two times. Okay, one is T1 and one is T2, and T2 is greater than T1. So with more time, what changes you can see? Anyone else with the answer? C. So we are getting mixed. So what do you think, like if we are focusing on advection, uh, is the concentration going to change with time? Any answer? If we are looking into advection, is the concentration going to change with time? That is the question. So here the graph is like based on distance and concentration. Suppose a river is flowing, okay, there is a pollutant. As we are going on through the distance, is the concentration going to change? Yes or no? Is it? So the correct answer for this question is A, right? So we will discuss how. Suppose, so uh, in advection, there is movement of the contaminant or whatever particle due to the bulk action of the fluid. So there is only movement. There is not going to be any change in the concentration. So that's why in the first graph, if you see the distance in the x-axis, as the distance is increasing with time. So time and distance are interrelated, right? So if the distance increase, the time also will increase. Okay, so here you can see as the distance is increasing in the x-axis, there is no change in the concentration, right? Are you able to see it? So that's why the first graph depicts advection. Whereas for the diffusion, with time, there is a change in the concentration, or with the distance, there is a change in the concentration, right? And when both are happening, advection and diffusion, and the flow pattern, like the change, like the graph shape is changing, because there is a part of advection also, and then there is a part of diffusion also. So that's why there is a change in the shape of the graph. Is it okay? We will see in much more, because there are some formulas which we'll go through in the next lecture. So there we will see how the formula is changing and how the concentration will be changing. And I have one question also in the last, we can see that. But for now, you can just remember that advection doesn't, it transports the particle from one part to the other part, but there is no change in the concentration. The concentration remains the same. Whereas in the case of diffusion, with time, it keeps on changing, right? Next question. After the London cholera outbreak case study, how was the water treated to control the epidemic? We just we have discussed some part of it. So one answer is sand filtration. There is one more answer. There is one more correct answer. So actually the correct answer is A and C. So both chlorination and sand filtration was done. So you can see in 1854 there is a cholera epidemic through water in London, and this was less severe in the places where there were sand filters were installed. So you can see due to that installation of sand filters, there was some changes in the outbreak. Okay, so it was less. And John Snow, what he found that this outbreak was caused due to the water pump contamination by sewage water, and he tried to disinfect the water with chlorine. So there is a part of chlorination also being done. So both the sand filtration and chlorination were helpful in the uh, in curbing the cholera outbreak, right? So after that, the government started installing like the sand filters everywhere, and some part of chlorination was also being done. Next question. Turbidity gives us an idea about dissolved solids, BOD, suspended matter, nitrates.
Suspended matters.
So suspended matters only because the measurement of turbidity depends on the scattering of light. Okay. So scattering of light, and it is only caused due to the suspended particles that are present in the system. And high levels of turbidity generally indicate poor quality of water. Okay. So that's why suspended matters gives an idea about the turbidity. Now next problem. Select the reasons why we choose coliform as an indicator of pathogens. So when we want to find out how much pathogens are present, we use coliform as the indicator organisms. There, because there can be n number of microorganisms present in the system. But to identify pathogens, we use coliform as an indicator organism. We saw in the previous one of the previous problem also. So why is it? What is the reason? Is it because it is present in intestines of warm blood animals and humans? It is harmful to humans. It is present in great numbers, so it can be easily measured, or it has a low survival rate. A and B. Okay. Are coliforms harmful? See, we have to measure it on a day-to-day basis. If they are harmful to humans in most of the cases, then how we are going to measure it again and again? So generally, it is present in the warm-blooded animals and humans. So that's why, due to their availability, okay, due to their presence, it's an easier indicator organism. And also, they are present in great numbers. Okay, so it can be easily measured, right? So the presence of coliforms will directly relate to the presence of pathogens. Okay, so option B and D are not correct. Option A and C are correct, right? So the same thing has been discussed in the detailed solution. Like these coliforms comes from the same source as the pathogenic organisms, and they are easy to identify and present in large numbers. Okay, and found in the intestines, and it responds to the environment, wastewater treatment, water treatment, similarly to the pathogens. So that's why we use them as the indicator organisms. Next question. Select the correct sequence of a typical wastewater treatment plant. Very simple. Just give me the answer. There is no point of discussing this. Yeah, so the correct answer is A, because first we will do the grid removal. Okay, so basic schematic, influent is coming, first the screen, then the grid removal, then the primary clarification, then we will move on to the secondary where we have the aeration tank and the secondary clarification. Then we move on to the tertiary where we have different kind of filters and the disinfection, and then final effluent. Okay, and from all the clarification points we will get some sludge, so it will go to sludge digestion. So option A is the correct answer, right? Okay, a small numerical. The concentration of MgSO4, magnesium sulfate, in a solution is 360 gram per liter. Its concentration in moles per liter is, what is the concentration of MgSO4 in moles per liter, or what we call it as molarity. Please try to solve it. So what is the first step? So first you have to find out the molar mass of MgSO4. So what is the molar mass of MgSO4? Can someone tell me? What is the molar mass of MgSO4? Option A. Please check your answer again. I think you're taking too much of time, so we'll discuss it. So the correct answer is 3 molarity. So if you see 1 mole of MgSO4 is 24 plus 32 plus,
64.
yeah. So it will be around 120. Okay, 120. So 120 grams. So if you divide by 360, it will be 3 molarity. I think there is a small mistake. It should be 64, not 48. Okay, just keep a note of it. It's not 60, it's not 48, it's 64. So 24 plus 32 plus 64, right? So it will be 120, right? So it will be 3M, 360 by 120. Next question. 200 milligram per liter calcium is present in the water sample. Okay. Convert the concentration to milligram per liter as CaCO3. So we have to find out in terms of milligram per liter as CaCO3. And the concentration given is 200 milligram per liter. Please try to solve this. So there are two concepts now. One we have for calcium and one is for calcium carbonate. Any answer? Okay, we'll see
Please
how.
solve.
Okay, let me solve it for you. So for this is 24th question. Okay, so first we will find out the equivalent weights of calcium and CaCO3. So equivalent weight of Ca2 plus. Okay, so what is Ca2 plus? So for calcium it's 40. So since it is 2 plus, it will be by 2. So it is 20 gram per equivalent, right? 40 by 2. Now we have to find out in terms of calcium carbonate. So we should know what is the equivalent weight of calcium carbonate. So equivalent weight of CaCO3. Okay, so it is 100, molar mass is 100. The combining capacity is again 2 because it's Ca2 plus and CO3 2 minus. So 2, so it will be 50 gram per equivalent, right? Now, now we have to find out calcium in milligram per liter as CaCO3. So what we have to do? We have to take what is the given concentration. Okay, we have to take what is the given concentration. We have to divide it with what is the equivalent weight of calcium 2 plus and then multiply with the equivalent weight of calcium carbonate. Okay, so we will get in terms of calcium carbonate. So what is the given concentration? Given concentration we have is 200 milligram per liter of Ca2 plus, right? What is the equivalent weight? It is 20 gram per equivalence Ca2 plus, right? And what is the equivalent weight of CaCO3? It is 50 gram per equivalence of CaCO3. Okay, so if we solved it, 10 into 50 is 500 milligram per liter as CaCO3. So this is the answer. Okay, is it fine? So yeah, so basic formulas by this way only I will tell you by solving problems. So just make a note of it. So whenever we want to convert some units in terms of CaCO3, so this is what we have to do. So we have to take the given concentration in milligram per liter. We have to divide it with the equivalent weight of that element for which it is given, the concentration is given, and then multiply with the equivalent weight of the CaCO3. Okay. So by this way, you please make a note of it. This is clear, right? Okay. We'll move forward. Okay, next problem. What drives the process of diffusion? What drives the process of
Option
diffusion? Option B.
B.
Okay, option B. So that is concentration gradients, right? So that is correct answer because this diffusion is the net movement of anything, maybe atoms or molecules, from a region of higher concentration to a region of lower concentration. So it is driven by the gradient between the difference of the concentration. Okay, difference or gradient between the concentration. So option B is the correct answer. I hope this is very simple for all of you. Next problem. What is the mathematical expression for Fick's law of diffusion? So again, we are talking about diffusion. So we are talking about concentration gradient, right? So what will be the correct expression? So J is the flux, okay. D is the diffusivity constant, and dC is the change in the concentration, and dt is the change in time. Dx is the change in the space or change in the distance. So what expression correctly depicts the first law of diffusion? Or rather, just the diffusion. What is given by this flux of a diffusion. Any answer? Just think in terms of concentration gradient. Is it the simple thing is two things have to be kept in mind, whether my concentration will increase or decrease with time. Okay, so that thing you can see in which of the option it is increasing or decreasing. The next thing is whether it is changing with respect to time or is it changing with respect to space. Two things are there. Any guess or anything, you can please try it.
Sir,
I think your voice is not clear. Can you please write it in the chat box, your option? Whatever is you are feeling is the correct answer. So first thing, the concentration is going to increase or decrease with time or space, whatever it is. Is it going to increase or decrease? It is going to decrease, right? So definitely there will be a negative sign. Okay, and it changes with space. Okay, so what it says that the fixed first law of diffusion states that the substance will diffuse from areas of high concentration to lower concentration, and also it guarantees that it will reach a steady state where the concentration or particles per unit volume will be same throughout the time. Okay, given enough time. Okay, so it is the change with respect to space, that's why dc by dx not dt, and it is decreasing, so that's why the negative sign. Okay, so this is the correct option for 26th problem. Okay, so now a few numericals are there, so let's try to solve it as soon as possible. So the first question says that hydrochloric acid reacts with sodium hydroxide in 1 is to 1 molar ratio to produce water and sodium chloride. Okay, a solution contains 30 ml of 0.5 molar HCl. Determine the volume of 0.75 molar NaOH solution needed to completely neutralize the acid. Okay, so this is the basic problem where we have HCl which is reacting with NaOH in 1 is to 1 molar ratio. So how much ever we are adding HCl, the same amount we are adding uh, sodium hydroxide. Okay, in the molar ratio, in terms of molar ratio, we are saying 1 is to 1. Now, this solution is having 30 ml of 0.5 molar HCl. So, what will be my volume of NaOH if the molarity is 0.75? So, this is the basic question. Okay, so don't get scared of this question. We'll solve it. Let's see. Okay, how to do this. Okay, just I hope you have taken a note of this problem. So question number 27. So what we are saying is we have HCl. Okay, it is reacting with NaOH. Okay, and it is giving H2O plus sodium chloride, that is NaCl. Okay, so this equation, as you can see, it's already balanced. Already balanced, and the molar ratio is 1 is to 1. Okay, so now, and we are saying that HCl is 0.5 molar, okay, for 30 ml. Okay, and we know NaOH is 0.5 molar, but we don't know how much ml. That this is what we have to find out. How much ml will react with this HCl? Okay, so what we will do first, we will see what is known to us. This is known to us, 0.5 molar HCl of 30 ml. So we will find out the moles of HCl. So what will be the moles of HCl? It will be the molarity into volume. Okay, because what you know, basically we know, so generally what we will do, we will write molarity M as moles of anything divided by the volume. This is how we define molarity, right? So what will be my moles? Moles will be molarity into volume. Now molarity is 0.5, okay, 0.5 molar into what is the volume? 30 ml, or we can write 0.03 liters. Okay, so it is 0.015 moles. It is 0.015 moles. So now we know that we are using 0.015 moles of HCl. We know this. And we also know that in this reaction, the molar ratio of HCl and NaOH is 1:1. So the amount of the moles of HCl that we are using, the same number of moles of NaOH will also be used because it is in the ratio of 1:1. Right? So, so now again with this formula we can find out the volume. So what will be my volume of NaOH? So now we want to find the volume. So it will be moles, right? Moles divided by the molarity, divided by the molarity. So now moles I know because same HCl moles, it is equal to the same HCl moles because of 1:1 ratio. And what is the molarity? Molarity is 0.75 m. Okay, so what will be my m, or I can write it as moles per liter. So moles will get cancelled, per liter will come. So we will get as 0.02 liter, or I can write it as 20 ml. So 20 ml of 0.75 molar NaOH is required to react with the HCl that is present in the system. Is it okay? Are you able to follow? Anyone has having any doubt regarding this? These kind of small calculations we have to do. Okay, okay, we'll move forward. We'll do one more problem, similar kind, but a little advanced. This was very easy. So please make a note of this question, or you can take a screenshot. We will solve it right now. It's a bit lengthy, and so it says that iron. Yeah, Mr. Om Dumane, you want to say something? Okay, I think it was by mistake. So it says that iron 3 oxide reacts with carbon monoxide to produce iron and carbon dioxide. So again a relation is given. A sample of 20 grams of iron 3 oxide is reacted with 10 grams of carbon monoxide. Okay, so the amount is given. Here the moles are not given, the amount is given. Determine the limiting reactant, the theoretical yield of iron, and the excess reactant remaining. Okay, so three things are being asked. So just take a screenshot. Okay, just take a screenshot. We will solve the problem. So what was the reaction given? It was iron 3 oxide, that is nothing but Fe2O3. Okay, Fe2O3. Plus we have carbon monoxide, that is CO. This reacts and gives Fe plus CO2 ferrous, and we have this carbon dioxide. Now we have to balance it first, because before proceeding we have to balance. So for balancing we will add 3 in front of carbon monoxide, 3 in terms front of CO2, and to balance the Fe we will add 2. So this is how simple balancing which we have learned in school. Simple balancing we have to. Now they are telling that Fe2O3 was 20 grams and CO also was given as 10 grams. So this is the reaction. So these two are added. Now always remember, it is not necessary that how much ever you add, okay, the total amount will react. Okay, so it always reacts in terms of the number of moles. So here we can see that 1 mole of Fe2O3 requires 3 moles of CO. Requires 3 moles of CO. So there will be some part which will be left over, either Fe2O3 or either CO. Okay, whichever will be lesser, it will act as a limiting reagent. Whichever will be lesser, it will act as a limiting reagent. Don't go in terms of the mass, 10 grams or 20 grams. Don't go in terms of mass. Always see how much of moles are present in the system. Okay, always remember, we have to see the number of moles. So we will calculate. First part, we have to find the limiting reagent. So which one have will be lesser? It will be the limiting reagent, right? So 1 minute. Am I clear? So can someone tell me how many moles of Fe2O3 are present here? We know the grams. So how much of Fe2O3 moles is present? Try to calculate. Find out the molar mass. So we have 20 grams. Okay, so what is the molar mass? Molar mass of Fe2O3 is 159.69 grams. Okay, so number of moles will be equal to 20 grams per 159.69 grams, right? Is it okay? So it will be 0.125 moles. Now similarly, we have 10 grams of CO, right? We have 10 grams of CO. So it will be 10, number of moles will be 10. CO is 12 plus 16. So it will be 0.375 moles. Is it okay? Is it fine to all of you?
Okay, sir. Okay.
Okay. So now if we multiply 3 into 0.125, okay, we are getting 375, and it is greater than the 0.357 moles of CO. So that's why CO is the limiting reagent. Right, whatever will be less, it will be the limiting reagent. Fine, so this is the very simple first part. Now if we go to the next part, what do you have to find out? So what will be my yield? Now 3 mole of CO in the question we have seen, it gives 2 moles of Fe, right? So for 0.357 moles, okay, of CO, how much of Fe we will get? We will get 0.357, simple mathematics, into 2 by 3 moles of Fe we will get. So what will be the answer? We will get 0.238 moles of Fe. Okay, so what is 0.238 moles of Fe? We can also write 0.238 into what is ferrous weight? It is 55.85 gram per mole. Okay, so for Fe, so we can get 33.3 grams of Fe. So this is the yield what we were talking about. Simple. For 3 moles of CO, we will get 2 moles of Fe. So that's why for 0.375 moles of CO, we will get 13.3, or we will get 0.238 moles of Fe. So we will get 13.3 grams of Fe. Simple. So if you have having any problem on understanding these things also, you go back, see the lecture again. Okay, come back to this question. Just see the basic formulas of molarity, molality, moles and everything. Come back to this question. It will be there in the YouTube channel, and then you can see, you will able to understand better. Okay, so now the last part. So here the last part is we have to find out what is the excess reactant. Okay, so we have 3 moles that reacts with 1 mole of Fe2O3. 3 moles of CO. CO reacts with 1 mole of Fe2O3. So for 0.357 mole of CO, how much Fe2O3 is required? How much Fe2O3 is required? So it will be 0.375 into 1 by 3 Fe2O3, right? So it will be 0.119 moles Fe2O3, or we can write 0.119 into 159.7, that is the molar mass, okay, gram Fe2O3, or we can write 19.03 grams of Fe2O3. So this much amount is required. But in our system, we have 20 grams, right? In the earlier we have seen we have 20 grams. So what will be the leftover? So 20 minus 0.19.23, it will be 0.97 grams Fe2O3. So this one will be leftover. Right? Very simple. You can easily do this. Okay. I hope it is clear. I have solved it step by step. If you have any doubts, you can get back to me, or you can see the lecture again. Okay. If you don't know the basic formulas, just go through the lectures once more, write down the formulas, and then try to solve this problem again. Okay. So for the interest of time, we will go to the last problem for today. So there's others who are able to solve this, they can go through this problem. So this is a kind of I'm giving as a workout problem for you. Okay, because this is a very big problem, but I don't want you to solve the full problem. If you can, it's very good. You can send me over mail, or else we will solve the first part of the problem. So it says that a river is flowing with a discharge of 12 into 10 to the power 6 meter cube per day, having a contaminant X of 1 milligram per liter. A wastewater is being discharged in the river with the concentration of the same contaminant X of 400 milligram per liter at 0.5 into 10 to the power 6 meter cube per day. So we have a river and we have a wastewater. So both are getting mixed at a point. So the flow rate and contaminant concentration is given for the river, and the flow rate and the contamination concentration is given for the wastewater also. Now you have to find out the initial concentration of the contaminant after the mixing. So both are getting mixed. So what will be the initial contamination? So can someone tell me what concept we have to apply for this question? Any idea? Have you ever solved this kind of problem? What concept we have to apply? If two things are getting mixed together, yes, any. So we have to see the conservation of mass, because mass of the contaminant will not change. Okay, we have to conserve the mass. So we will quickly see the rest part. I'm not solving today. We will get back to this question again after going to week 2 lectures. If anyone can solve, they can try it and send it to me over mail. But for the first part, we will just see what is the answer. So it is 29th problem. So for the river, the discharge is 12 into 10 to the power 6 meter cube per day. For the wastewater, it is 0.5 into 10 to the power 6. Now, concentration in the river is 1 milligram per liter. Concentration in wastewater is 400 milligram per liter. So whenever we are conserving the mass, we should always remember that quantity into concentration of the river plus the discharge into concentration of the wastewater will be equal to the final discharge into the concentration of the that mixed thing. Okay, so by this is the conservation of mass. So now we have to just input. So QR is 12 into 10 to the power 6 into 1 plus 0.5 into 10 to the power 6 into 400 is equal to QF. What will be QF? Final QF will be addition of both. Okay, so 12 plus 1, sorry, 12 plus zero point 0.5 into 10 to the power 6. Okay, so this is the total flow rate into CF. Okay, so if we solve this equation, we will get CF as roughly around 16.96 milligram per liter. So this is how you have to solve by conservation of mass. So this is the first step of the problem. The rest part, so I hope this is very easy. So this is that, so when we do QR into CR or anything, like suppose we are multiplying discharge into concentration. What is discharge? Discharge will be always in terms of, suppose, what is the discharge? Cubic meter per day. Okay, into concentration will be milligram per liter. Now liter and meter cube can be interchanged, or like I can type write in terms of meter cube also instead of liter, so this will just cancel. So ultimately we will be getting milligram per day. So this is nothing but mass per day. So for a particular period of time the mass will be conserved, mass is not going to change. Okay, if two things are mixing for a particular period of time, the mass is not going to change. So that's why we are conserving the mass. So at the point of mixing where the two wastewater and river is getting mixed, the mass will be constant. So by this formula only we can find out the answer. Okay, I'll just roughly tell you the second part. The second part says that suppose there is a decay of the contaminant happening at some rate 0.8. We have to find out the concentration of the contaminant at 8 kilometers from the point of mixing. Okay, so for in this we have to bring into advection, diffusion, and in this problem it is saying that we have to neglect the diffusion. So we have to just incorporate advection and the decay of the contaminant. We have to make one formula, we have to make one equation and then solve it. So we will get the concentration of the contaminant at 8 kilometers from the point of mixing. We will get into this later after the week 2 lectures. But if any one of you wants to attempt this or wants to get some idea, you can mail me. Right, I will give you the answers. So for the initial concentration, it's 16.96, what we got. For the concentration at 8 kilometer downstream, the answer is 6.09. If you can solve it and get the answer, it's fine, or else we'll discuss in the next class. Okay, so this was all about this week's lectures. Thank you very much for attending this lecture. And the next session will be on 4th February. Okay, and same time 7 to 9 p.m. on a Tuesday. And this is my email address, saha19akash@gmail.com. So if you have any queries regarding these 6 lectures or any upcoming lectures, you can drop a mail. So that is the preferred mode of contact. You can just drop a mail, any question, any problem, I will try to solve it. So in my capacity,
Excuse me, sir.
yeah.
Sir, could I receive any participating certificate this online?
Yeah,
Tutor?
certificate, if you register for, if you go through the whole certification course, do all the assignments, submit it, and then register for the final exam. Okay, so at
Yes.
the end of the final exam, you will be getting a certificate that you have completed this course with this much marks. It will be there.
Okay. Okay, sir. Thank you. Thank you.
Any other queries? If you are,
No, no, sir.
yeah, if you
No,
are
sir.
done, yeah. Someone else was trying to say something. Please go on.
Sir,
Yeah.
Sir, is a recording of this session is available?
Yeah, it will be available. It will be shared to you, or you can like today I have taken the class, so most probably by tomorrow I will upload it. By tomorrow morning I will try to upload it. So you can go to my YouTube channel. You can, I am writing in the chat box. You can just type in Akash Saha NPTEL. Okay, Akash Saha NPTEL. See, problems will be there in the final exam. Definitely problems will be there, but not of subjective type, but in MCQ type. So anyway, small problems, but in MCQ type it will be there. And mostly this is a numerical, so you can, I can't say the weightage, but it will be there. More problems will be there. Yeah, you will get this presentation. You will get the link for this YouTube recorded lecture. Everything you will get it by mail through NPTEL team. Okay, no problem. You'll get it. Or you can go to my NPTEL channel. Thank you so much. Thank you. If you don't have any more queries, you can leave the session. That's all for today. Thank you, Stephen. Others, if you don't have any queries, you can leave the session. Thank you. Thank you.